to introduce Professor Mauro Picardo. Professor Mauro Picardo is from Rome. He is now working at the Unica Melius International University in Rome. He was working first in San Gennaro Institute. Professor Mauro Picardo is very well-known expert in vitiligo. He made a lot of work, not only in the immune part, but also and mainly on oxidative stress and all the cells that are very important, the keratinocyte, fibroblasts, and of course melanocyte. And he made tremendous advances in the knowledge in vitiligo. And he was with Professor Alain Tayeb, one of the founders of the VETF, and he has, of course, made a lot of congresses, made more than 380 publications with H-index of 67. Mauro, the floor is yours. Thank you very much.
Thank you very much for this nice introduction, and thank you for the organizer for inviting me to be one of the speakers of these relevant meetings. Just yesterday I learned a lot about vitiligo from the experience of the Indian colleague. It was very interesting to attend to this presentation. So today we try to speak about the possible source of oxidative stress in vitiligo. Why to speak about that? Because if we look for most of the cartoon of the scheme where the possible pathogenetic event related to the appearance of vitiligo are represented, oxidative stress is now present in most or almost all of them, independently from the author. So this is an important situation because not necessarily in any other chronic inflammatory skin diseases oxidative stress is so specifically reported as possible mechanism of appearance of the pathogenic role of the oxidative stress. But oxidative stress may be related to a lot of events. We know that UV exposure can produce oxidative stress, air pollution can produce oxidative stress, an inflammatory situation can produce oxidative stress. So to identify which could be the source of oxidative stress is absolutely relevant to try to contrast the stress, to try to inhibit the generation of free radicals, and particularly to try to inhibit the generation of the damage induced by the oxidative stress. So I take to evaluate which could be the possible source of oxidative stress, evaluating which is the possible role, why this is speaking about oxidative stress in vitiligo. Because it's considered there are some role of the environmental pollution, UV exposure, because there is a possible role of the inflammatory infiltrate, the catecholamine release. There is a recent paper from David and Parsat that underlined that catecholamine can be released by skin cells and may have a role in vitiligo. Possible cellular metabolic processes such as melanogenesis are considered as possible source of oxidative stress in vitiligo. And our group has reported some abnormal energy metabolism in mitochondria. Oxidative stress is basically an alteration between the balance between free radicals and the antioxidants. So it could be related to some reduced expression of antioxidant enzymes. This has been reported since several years of catalase. Reuter started with these topics with the reduced expression of glutathione reductase, thyroidoxine reductase, and some other enzymes, such as also the alteration of the nuclear factor E2 that control the activation of the gene for most of the enzymatic antioxidants. So there are several links to stress. And the membranes and then can amplify the process producing some DNA damage. Basically, oxidative stress will be capable to activate autophagy, which could be one of the possible mechanisms of disappearance of the melanocyte. But even this other mechanism, apoptosis and ferroptosis, that could be activated by the generation of oxidative stress inside the cell. So There is evidence that there are some marker oxidative stress. There are evidence that intracellular oxidative stress, or possibly even some extracellular oxidative stress, will be capable to activate different mechanisms of the disappearance of the melanocytes. But what we can have evidence that antioxidants works in vitiligo, and how could be used antioxidant vitiligo? So there are probably antioxidants, even if we discuss a lot during our meetings between oxidative stress, the role of antioxidants, probably antioxidants is one of the most common prescription provided to the patients with vitiligo. Independently to the idea of the different dermatologies, most of the patients receive the indication to take antioxidants just to protect generically the skin, and possibly even to protect the depigmented skin. But certainly there is increasing evidence that antioxidant supplementation alone in combination with other conventional therapy may serve as promising strategy for vitiligo patients, not necessarily as a promising therapy, but a possible promising strategy. Oral antioxidant supplement may serve a convenient approach with good safety profile. The antioxidant supplemented by different type of natural antioxidants from ginkgo biloba or polyunsaturated fatty acid, polypodium, carotenoids, have been reported to increase the response of the phototherapy in vitiligo patients. But there are no clear evidence that the antioxidants alone are able to elicit significant repigmentation. So probably antioxidants are not capable to induce repigmentation in most of the study, but they're likely to provide additional benefit as adjunctive approach to conventional treatments. This is an important point to identify which antioxidants we can use and how we can use antioxidants. Experimentally in vitro, we know that the antioxidants works in a sort of chain. We cannot provide just one antioxidant, I don't know, high level of vitamin E, because this modify the chain of the antioxidants, the chemical and enzymatic antioxidants. This is the scheme. Basically, vitamin E is the first line of treatment because vitamin E is a lipophilic antioxidant present on the membrane. This is oxidated by the free radicals. Vitamin C reduces vitamin E. The oxidation of vitamin C is restored by glutathione, reduced glutathione, and then when glutathione is oxidated, an enzymatic system which utilizes NADPH reproduce again reduced glutathione. So we cannot increase just one antioxidant because this alters this equilibrium. And what is important that the intracellular antioxidant cell level tend to remain constant. If in vitro we increase the level of vitamin E in a culture of melanocyte, we have noted that the level of catalase decrease. So we will create some imbalance among the chemical and enzymatic antioxidants. So probably, in our idea, the best approach is to provide a pool of physiological antioxidants, combination of vitamin C, vitamin A, vitamin E, beta-carotene, lipoic acid, just to try to maintain the right equilibrium in the patients and not to provide continuously antioxidants, just not to have a significantly higher level of antioxidants, but just to have a moderate level of antioxidants. So speaking about the possible source of oxidative stress, some years ago we demonstrated that there are some intrinsic metabolic defects in vitiligo melanocyte. We demonstrated that there is an increased generation of active oxygen species in melanocytes from pigmented skin of vitiligo patients. This is associated with an alteration of morphological alteration of the mitochondria. It is associated also with an expression of some senescence marker of these cells detectable in vitro and even ex vivo with an overexpression of P53 and the P53-dependent protein expressions such as GAT45 and PML that are markers of aging of the skin. We have demonstrated that this process is not exclusively related to the melanocytes, so it's not related to the process of the melanin generation, but even other cells, such as the fibroblasts, produce more level of reactive oxygen species and are associated with some morphological modification and expression of aging marker, such as P53 or metalloproteinases, and even the production of what is defined as senescence-associated secreted pattern, which include insulin growth factor binding protein 3, 7, interleukin 6, and some other growth factors. So it seems that a quite diffuse situation of the generation of free radicals among the skin cells, This seems to be associated also with the increased autophagic markers because antioxidants are capable to decrease the expression of autophagic markers in melanocytes and also in the fibroblasts. So there are some evidence, at least in vitro, that oxidative stress produces a modification of the behavior of the cells. And we believe that this modification is relevant to produce a deregulated interaction between epidermal and dermal compartments. So we believe that the altered biological expression of growth factors and factors of communication between the dermis and the epidermis may be related also to the detachment of the melanocyte for the basal membrane that is reported at the beginning from Yvon Gauthier and called as melanocytoregie, one of the possible mechanisms of the disappearance of the melanocyte. And more recently, we have demonstrated that also keratinocytes present some metabolic and morphological and functional alteration because there is a significant delay in the appearance of the differentiation markers in vitro produced by both expression or exposure to high calcium concentration or just to produce hyperproliferation, a high level of cells in vitro that are modeled just to induce differentiation. And we observed that spontaneously keratinocyte from pigmented skin of vitiligo patients release some inflammatory mediators such as interleukin 1, interleukin 6, and 6L10, and that after scratch test, the expression that tried to resemble a Kober phenomenon in vitro, the expression of these inflammatory mediators significantly increased, indicating that these cells are prone to be activated following any mild or even lower stressful event just to produce inflammatory mediators capable to recovery in other inflammatory cells, probably just capable to activate the dendritic cells to start with the autoimmune phenomenon. What we demonstrated looking for ex vivo that just collecting with the squamous, it is a sort of scotch, there is a difference in the amount of cornocytes that are collected from the skin of normal individual and those from the pigmented skin of vitiligo patients. So, there are a more compact stratum corneum in the vitiligo patients. And this is associated with a higher cholesterol level, a different expression of some differentiation proteins such as corneodesmosine, and is particularly associated with an alteration in the composition of the epidermal lipids. This indicates that there are some alteration in the barrier constitution of the epidermis in vitiligo patients that probably will be some biochemical basis for the increased sensitivity to any stressful event. This pattern of alteration, without going into the details that are just related to people like me and our group or looking at just in some labs downstairs in some places, there is a significant decrease of the ceramide, a significant higher amount of free fatty acids. It's something that we can observe in atopic dermatitis or that we can observe in ichthyosis. It's something similar to what we have observed in vitiligo patients. And this acceleration is associated with some intrinsic metabolic alteration in melanocytes with the which produce less ATP, which present some modification, the capability to metabolize glucose. There is a significant increase of the glucose uptake in vitiligo melanocyte, and there is some alteration of the expression of the enzymes correlated with the glucose metabolism. Probably there is an overexpression of an anaerobic glycolytic enzyme, a lower expression of the Krebs cycle. Probably there is a try to compensate the inability of mitochondria to work appropriately to produce ATP, increasing the expression of anaerobic glycolysis. Just to evaluate if this may be correlated with some modification of the capability to respond to insulin, which is the major hormone which controls the glycolic metabolism, Barbara Belay in our group checked for the capability of the vitiligo melanocyte to respond to the insulin. Insulin is normally present in the culture medium of any type of cells, particularly melanocyte. Vitiligo melanocyte respond lower to insulin growth factor. The response to its proliferation is significantly decreased, and also they undergo to a stressful event following the exposure of the insulin. This is the suggestion that something is wrong in the crosstalk between insulin, cell, the receptor in the cells, and then to the switch, the transduction of the stimulus for intracellular metabolism. Several papers, and there are some posters even here, are underlying that patients with vitiligo can have some metabolic syndrome. This is the report of 3 or 4 different papers. This is Darino et al. Is a paper from our group. We have demonstrated in about 800 patients examined in the last couple of years that is a lower level of cholesterol with LDL cholesterol triglyceride value higher than in control, but particularly there is a fast blood glucose uptake level significantly higher. So if you check for the glucose level and the insulin level in patients with vitiligo before and after a meal, we can see that the response is frequently altered with our hyperinsulinemic response or hyperglycemic response. So it seems that also in vivo there is some alteration in the glucose metabolism in vitiligo patients. So considering all that, we have taken consideration that to try to treat vitiligo cells with activator or peroxisome proliferating activating receptor. These PPAR are a ligand-activated transcription factor that works as transcription factor and then as a nuclear receptor, basically as well as retinoic acid, or the receptor for the retinoic acid, and also for vitamin D. One of the master regulator of mitochondrial biogenesis and function. These drugs are normally used clinically to treat diabetes. After heterodimerization with retinoid X receptor, PPAR produce transcription factor contributing to transactivation of genes involved in energy homeostasis and cellular differentiation. And PPAR gamma particularly have a central role in fat cell differentiation, lipid storage, vascular function, and energy metabolism. Moreover, this molecule has been demonstrated to have some anti-inflammatory process. And there are some reports of the use of high concentration of these drugs for treatment for psoriasis, for example. But because of possible side effects, they will not go in clinics. So we used that this molecule, in particular pioglitazone, which is one of the representative of these PPAR gamma activators in vitro. What we observed that, contrary to what expected, because they help the glucose income inside the cells, we observed that there is a reduction in the glucose consumption. It seems here that it's increased because we have measured glucose outside the cell in culture medium. And we observed that there is the decrease of the expression of, there is a stimulation of the expression of lysokinase, the pyruvate kinase mechanism. Basically, it was an improvement of the glucose, intracellular glucose metabolism. This is associated with the decrease of the process of the metabolism of fatty acids, so that it was a switch towards glucose metabolism rather than to lipid metabolism that seems to be mostly used by vitiligo melanocytes. And this is associated with the different expression of mTOR. I don't want to go into the details of these experiments because it becomes more complicated. But we observed that there is an increase of mitochondrial DNA content, so was improved the generation of mitochondria. It was an aggregate expression of PGG1 alpha that is an indicator of mitochondrial genesis, and this was associated with the decrease of the intracellular generation of active oxygen species. And with improvement of the membrane potential of the mitochondria, and at the end, basically, we observed the increase of the production of ATP, so there is an increased generation of the energy metabolism inside the cells, and this is associated with an increased proliferation in vitro of the vitiligo melanocyte. So basically, the meaning generally is that there is an improvement of the metabolism of the cells following the treatment with this drug, and this was associated with the decrease of the expression of some senescence marker of the vitiligo melanocyte, such as EGF binding protein 3 or P16, or EGF binding protein 7, and even to the decrease of expression of MTF that is overexpressed in vitiligo melanocytes as a sense of, a marker of senescence. And again, also some markers that are considered capable of the release of some factors that are included among the DAMPs, so molecules capable to activate the dendritic cells, are reduced following the treatment with these molecules, such as the expression of PDL1 that is increased in the vitiligo melanocyte, the expression of CC3 beta that Thierry has shown as a relevant mechanism for the disappearance of melanocyte in vitiligo, and even for some other major histocompatibility associated antigens. So basically what we observe is that there are some metabolic modification with an improvement in energy metabolism, reduced expression of gene involved in beta oxidation and Krebs glide, restored metabolic network, and this was associated in vitro with some relevant biological modification of the vitiligo melanocytes. We have even some clear evidence that this works also for fibroblasts and even for keratinocytes, but I do not present all this data. So this is a scheme that is published very recently, which demonstrates how altered metabolic process can be capable to induce a metabolic stress on melanocytes and will be capable to produce some damage on the melanocytes, indicating that really if we work in improving the metabolic process, we can decrease the oxidative stress inside the cells and we can increase or we can improve the biological behavior of these melanocytes. And there are several data which try to correlate the function of the immune cells with the metabolism. It is called immunometabolism. There are several evidence how lymphocytes were activated, they use one type of metabolism or the other type, and the differences in the glucose or lipid metabolism among the different subsets of the lymphocytes. It's a quite interesting new way to approach immune-mediated diseases. Certainly, as Julien Sénéchal has suggested, it could be that a minimal inflammatory process occurring even in pigmented skin or vitiligo patients could be the source of this alteration. But I believe that since we work with cells in vitro at the fourth or fifth passage, probably these cells that is the fourth or the fifth generation with respect to the cells taken from the skin, they lose some of the markers eventually produced by the contact with some inflammatory modulators. In any case, Julien had demonstrated that there is an increase of the metabolic activities following the exposure of normal melanocyte to gamma interferon, not necessarily an imbalance of the energy production. So what you can say that there is some links between metabolism and cell behavior. It is reported that there are specific skin cell populations are also involved in critical role in the regulation of metabolic pathways, including melanocyte, keratinocyte, and tissue-resident memory T cell in vitiligo pathogenesis. So it's confirmed even from other groups that could be some correlation between altered metabolism and abnormal biological behavior of these cells. And there are, in this paper, a very interesting paper, Network Metabolomes, that we can switch the functional of fibroblasts toward the production of growth factor or extracellular matrix if we will be capable to control the metabolism of the fibroblasts, inducing more glucose-dependent metabolism or more lipid-dependent metabolism. And this paper, they demonstrate that they will be capable by this way to reduce a fibrotic response in animal models following X-ray irradiation. It's quite interesting how with the energy metabolism to try to identify something in the difference in melanocyte behavior. So, which could be the conclusion? That we can say that possibly there is a relevant in the pathogenesis, the generation of oxidative stress in vitiligo, that possibly this is correlated with the metabolic abnormalities, that possibly antioxidants are useful, but just as complementary therapy, and the probably cycle or combination of physiological antioxidant could be the most appropriate approach. And probably the correlation between metabolic alteration and the correction of metabolic alteration is probably the right approach to treat vitiligo patients and to decrease the oxidative stress. Thank you very much for your attention.
Thank you very much, Mauro. It was very, very interesting. If there is any question in the audience, maybe I can start. Oh, sorry. Please. Okay.
Very nice talk, Professor Picardo. I was very intrigued by the mitochondrial data that you showed. Mitochondria are also important organelles for the apoptotic death of cells. They control the caspase-mediated death. What are your thoughts on melanocyte loss in terms of senescence versus death by apoptosis?
Not necessarily the melanocyte loss is related to a senescence-dependent mechanism, but senescence mechanism is one of the markers of vitiligo melanocytes. What we believe that these cells are ready to release some dams even with very low stressful event. This is what we basically observe with the Kuber phenomenon, that a mild or low stress event, physical stress is capable to activate the immune response to lead to the disappearance of the melanocytes. So we believe that the alteration of the mitochondrial metabolism allow the cells to release easy SPH70 and other DANs that activate the dendritic cells. This is what Thierry Pasternak demonstrated in a very nice paper in Nature Communications some years ago. And then these cells, these dendritic cells, are more prone to release inflammatory mediators to recruit immune cells that there is so the presentation of antigens to the immune cells and the development of that immune phenomenon. So we believe that this mechanism could be an initial event for the development of that immunity in vitiligo. And probably we can try to inhibit the spreading of the disease. We will be capable to improve this metabolic aspect of the skin cell. This is our hypothesis.
Okay, thank you. If I may have one more question. So, I mean, that is on, you showed about alterations in free fatty acids and ceramide levels in the skin. So does it have an alteration in transepidermal water loss or barrier function?
No, there is no alteration of transepidermal water loss because basically what you observe is that the stratum corneum is more compact. Basically the situation from a biochemical point of view and even from the evaluation of transepidermal water loss is more similar to what we can observe in ichthyosis rather than in atopic dermatitis. In fact, we observe that there is this increased level of cholesterol that is one of the characteristics of ichthyosis. Cholesterol allows the corneocyte to remain more compact. So we do not observe the increased transepidermal water loss, but eventually transepidermal water loss is even lower than the mean value in normal subjects.
Professor Picardo, I'm very interested in these metabolic defects in melanocytes, but I wonder what is the correlation between these defects and the defects in the proliferation of melanocytes?
Yeah, because if the cells are not capable to produce enough energy, they do not proliferate. So any inhibitor of energy metabolism is basically an inhibitor of the cell proliferation. Yeah. So if we were capable to improve, if we increase the generation of ATP, certainly the cells, they have the energy to undergo, to start a duplication.
So I also believe that the major defect in vitiligo is the melanocyte itself. That's my impression.
Probably, in our hypothesis, not exclusively melanocytes, but could be some a more systemic metabolic alteration that could be detected. And this could be reflected even from some of this determination, these reports of metabolic syndrome in vitiligo patients. This is our hypothesis. Of course, this is one of the hypotheses we have to check for the validity of as an hypothesis.
Thank you.
Thank you.
Dr. Picardo.
Thank you, Dr. I'm sorry.
Yeah.
The moderator has to control.
Please go ahead. Yeah, it's an important discussion. Please.
Yes, I mean, super excellent talk, as usual. I know you are a scientist and a clinician. And oxidative stress, it's a talk that we always very interesting to hear from the scientists, but majority are clinician. So I never prescribe any vitamin or antioxidant in my clinic as a clinician. Unless I see something deficient from the vitamins, any lab test I do, I supplement from whatever vitamins. So what's your message for us as a clinician to prescribe as an antioxidant or in another way? Do you prescribe antioxidants or any vitamins blindly without doing any lab test?
Yeah, no. I prescribe antioxidants, and what I prescribe is this integrators, it's called, that are a combination of low level of vitamin E, vitamin C, vitamin A, beta-carotene, lipoic acid, ubiquinone, that are several present on the market. Because we believe that just the administration of something like polypodium or ginkgo biloba or resveratrol, there is no clear evidence that these molecules are capable to go inside the cells. And since we believe that the oxidative stress generated inside the cells, we need something that goes inside the cell. We provide to have, just what is defined as the normal ideal assumption level of these molecules, just to have a little higher level of these molecules in the tissues, but just to use 2 man yes and 2 man no, because you cannot overwhelm the level of antioxidants. The body is capable to control the level of vitamins. You cannot become a big bowl of vitamin E or a big bowl of any type of antioxidants. So just to increase a little bit the plasma level or the physiological level of these antioxidants, because probably they are consumed during vitiligo, and this can help. This could be a support together with other treatment, because certainly it's not capable to solve the problem. Because according to our recent indication, we have to think to improve the metabolic situation of the vitiligo cell to prevent oxidative stress rather than to inhibit the production of the molecules generated by the oxidative stress of the reactive oxygen species. This is our idea, and we hope that we'll be capable in the next future to start with some trials using some of these drugs to treat vitiligo patients and to follow what happened.
Last question.
Take in consideration that JAK inhibitor is capable to control some of the metabolic process. This is an important point, that just to have small molecules rather than monoclonal antibodies. Probably we can work in a wider way with respect to targeting just one specific cytokines or chemokines.
Thank you, Dr. Picardo, for an excellent talk. But me being primarily a clinical researcher, my question was somewhat similar to Dr.
Ahmed.
Yeah. So my question is also that would it make sense to do studies in which we use it as an adjuvant to standard therapy and have a control arm which uses standard therapy? So standard therapy plus antioxidants versus standard therapy alone, because the current level of evidence, if we look at the scientific literature, is not great for the use of antioxidants alone. So how do you think we should move forward on generating better evidence for the use of antioxidants for our patients?
Yes, again, before we were capable to demonstrate that modifying the metabolic situation, we were capable to improve the course of the vitiligo. Up to now, what I'm doing is just to produce antioxidants for at least 1 year in association with phototherapy, but even in association with topical tacrolimus. Just to what is our feeling. We have not just clear clinical data because we have not done more than one trial with one specific compound. But our feeling is that certainly the continuous, the alternative administration for a long term of antioxidants significantly decrease or contribute to decrease the spreading of the disease. So in association with topical tacrolimus or systemic phototherapy is capable to help the stop of the progression of the manifestation. That is relevant because the disease is the disappearance of the pigmentation. So not necessarily we can expect that inhibiting the disappearance of the pigmentation means that reappear the pigmentation. This is what I try to explain to the patients, so that we will be capable to stop the progression of we get a goal of our treatment.
Thank you.
Thank you very much, Mauro. Thank you very much. And